All right, so we're going to start off by, we've got a problem here, and we're going to go through that. Do you want to describe what the problem is, Dave?
So, basically, our problem with the PCI standard, or one of the problems, of course, everybody has a lot of problems with PCI. One of them we decided to sort of focus on was Requirement 6.6. And essentially, the problem is you have to do some sort of web application assessment, or you have to have some sort of web application firewall or a WAF in place of your payment applications that are externally accessible. So the problem that we're sort of seeing, definitely with other assessments, is when we go back and do more technical assessments on these web applications, they're still vulnerable, and a lot of times they're simple vulnerabilities that could have been picked up by simple means. So here's a little agenda about our presentation. So we're going to go over a brief discussion on PCI standard and also Requirement 6.6. So that's kind of the boring part where you I'll have to at least get you some of the knowledge and some of the background knowledge. But then we start going into our fail section, and that's where Gary comes in. And he's basically going to start showing some instances of how in real situations that these are simulated, of course, but a lot of times how we go into organizations and we're able to actually make these different things fail, or we bypass these different things such as web application firewalls, application scanners, peer code reviews, etc. And then we're going to have a little bit of discussion about some of my viewpoints from a PCI, from a QSA, and then Gary's going to talk about some of his point of views from an application assessor or a hacker.
Exactly. All right, so I am Gary McCully. Today I will be playing role of hacker. I'm a security consultant at Secure State. And at Secure State, I do all types of fun things. I get to perform physical penetration assessments where we actually try to break into organizations' physical locations with lockpicks and sneaking past guards and stuff like that. Also, I perform internal attack and penetration assessments, external attack and penetration assessments, wireless penetration assessments, you know, all types of, believe it or not, I even do some war dialing from time to time for all those who remember what that is. And then also, one thing I've been working on lately is developing and implementing vulnerability management programs. So,
I am David Sopata, and I am now a ex-QSA. So, meaning that I have not recently had left Secure State, pursued another type of environment, and but what I did is I actually assessed organizations for their PCI compliance. For a lot of level 1 merchants. And we'll get into some of those terminology in some of the other slides. Also, a lot of the other work that I did too was other risk assessments, understanding of different types of control frameworks, from risk to vulnerability assessments to understanding like HIPAA, ISO 27001 and 2, etc. So, a little disclaimer. Since I'm no longer with Secure State, and also I work for another type of employer, this is one of those disclaimers that they always have you do if you work for an employer that doesn't like you representing them. So essentially, this says that this presentation are of my own opinion. They do not reflect any past, present, or future employer. They do not actually represent any past or present positions on the PCI Council, QSA companies, or payment brands, or small puppies. So, for those of you who have not been living under a rock, this is actually a little bit of a pun if you haven't done PCI. We'll get into that. So, what is PCI? Well, what ended up happening was all the car brands, they want to try to prevent fraud. So what they did is they developed a bunch of security standards. And so from those security standards, they actually they made all their merchants actually do all this. So if you're a merchant, you actually took Visa, MasterCard, and Express, you would actually have to do security assessments for all 3 of those card brands. That was very cumbersome. So what they all did is they all sort of got together and created one big standard called the PCI DSS, or Data Security Standard. And PCI stands for the payment card industry. let's see here. So essentially, depending on how you process credit cards and how many levels of how many credit cards you actually process and how you process your credit cards is dependent upon what type of reporting you have to do. So either one, you have to do a level 1 ROC, which you actually have to have a guy like me or who I used to be go on site, perform an assessment, do an audit, and then say you either pass or fail, or you do what you call a self-assessment questionnaire or an SAQ. And so from that, you'd actually just say, you know, I'm good, and give it to your bank, and your bank says, okay, looks good to me. All right, so there's a little bit of catch to that first part. Level 2 merchants, in some cases, they have the ability to have what you call an ISA, or a information security assessor. So a QSA actually stands for a qualified security assessor. An ISA is someone that's internal to your network, that might be part of an audit team, that takes the same training that a QSA would take. Level 1, level 2, level 3, level 4, those are the different levels of merchants. So your level 1s are like your Walmart, your level 4s are your mom and pop shops that are just taking credit cards with a knuckle buster, or maybe even with a card swipe machine. Those will determine what type of assessment you have to do. Now, in some instances, if you're a level 4 merchant, you could potentially actually be required to do a level 1 assessment or perform a ROC, where I have to come on site and do an assessment because your bank considers you a high risk, and this happens when you become breached. So, a little bit about the actual standard itself. It has a lot of controls. It has over 220 some controls. So try applying that to your organization and making it fit within your organization. It's pretty rough. Also, there is some qualifications as to how you process your credit cards. Depending on how you're actually processing your credit cards will depend upon how many controls you actually have to potentially prove your compliance to. Generally, they always say that you have to comply to all the controls, but you only have to report on some of them. So, for instance, if you're just doing what I call the knuckle buster, where you do a card imprint machine, where you just swipe it over and it does like a little imprint carbon copy, that would be what we call an SAQ, or self-assessment questionnaire, a subset of requirements. So that would be about 20 controls. SAQB is when you have one of those credit card machines that hooked up to a phone jack or something like that. So you just swipe it in. That's probably closer to about 40 controls. SAQC and CVT are pretty similar but a little bit different. SAQC is when you have a validated payment application that you're using to process credit cards, and you have to abide by about 60 controls or so. SAQ-CVT is when you're using a terminal, such as like any computer, that goes onto a web browser that then connects up to another payment system online somewhere else. So all those systems that are using to process credit cards have to have compliant controls on them. It's about 60 controls. And then you have your Ds. It's not the grade that people get when they're doing their PCI compliance, but what it is all the controls. So that means that you're storing, processing, and transmitting credit card information. And that's very key with understanding the scope of PCI. So PCI, the scope of it, is all about credit card information. A PAN, which is the personal account number, which is your credit card number, and the expiration date. Technically, those are the only two things you need to process a credit card. However, a lot of merchant banks and processors require you to also use what you call the CVV code. There's several different versions or names of that CVV code, but it's a 3-digit number that's on the back of a credit card. So let's get into the meat of what we're kind of talking about. So that's sort of the background of PCI and some of the high-level stuff. If you guys have questions or whatever, you can feel free to talk to me after the presentation. But right now we're focusing on one control. And so this control is about publicly facing applications that process credit card information. You have to have either some sort of application assessment or application vulnerability assessment code review, or you can have what you call a Web Application Firewall installed in front of your web application. So if you look at what I highlighted, public-facing web applications. So that means the only thing that's required to be assessed is stuff that's facing publicly. Doesn't necessarily mean the stuff that's facing on the inside, but you have to have the stuff externally facing, definitely has to have a more scrutinized assessment done to it. So the intent of the control was really to try to ensure that we're protecting credit card information, because that's what it is. It's about fraud. And here are the things that we're trying to protect against. You see the requirement 6.5. Basically talk about all the different types of stuff. If you are familiar with OWASP, it is a standard for ensuring that you're doing secure code practice. And this is just a high-level overview of some of the different things we're looking for, such as SQL injection, cross-site scripting, the usual suspects. An additional layer, try to find additional vulnerabilities, is your normal other assessments that you have to tie in from a PCI standpoint. Now, depending on how you're processing credit card information, you may not be required to do a penetration test, vulnerability assessment, etc. However, with this one, a lot of times, if you don't actually store credit card information, your penetration testing and all that stuff, you don't have to do it, which is kind of amazing in my opinion. Reason why a lot of these controls exist is because something happened, such as the Heartland payment systems. They got breached. So when that happened, some of these other controls sort of came around. So here are the 4 options that you're allowed to do to meet that requirement. So we have the manual review of application source code, pure code review. Could also be third-party reviewing your code. Could also even be some sort of static code analysis, which is the second one as well. You can also do some sort of manual vulnerability assessment. So you can actually pop it through some sort of vulnerability assessor, do whatever. Also, another thing is that you can also potentially do is use some sort of automated scanning tool. So here's all the things from a web application firewall. So this is the OR part. So when you have the web application firewalls, these are all the capabilities it's supposed to have. I'm not going to sit here and list them all out for you, but some of the big ones is definitely you have to at least protect against the OWASP top 10, or assess things to make sure that you're looking for the OWASP top 10 vulnerabilities. Try to prevent data leakage. Try to prevent inspection of page content and underlying protocols. Also making sure that you have fail open. Also has the capabilities of prevent detect session token tampering, etc. What the other thing is too is being able to place it in the correct position. So if you put your web application firewall in the wrong place, it's not going to be able to actually inspect the traffic. So if everything's encrypted that's going through the web application firewall, well then you're basically mooting the point of having a web application firewall. You have to try to put it in the place where the encryption's been terminated and you can actually see the traffic that's coming through. So I'm going to turn this part over to Gary, and this is where things get a little bit more interesting since he gets to show you how he's bypassed all this stuff.
All right, so let me kind of give you a little context of why this became important to me. Well, you see all this stuff right here, right? I mean, I see these web application firewalls, are supposed to be in front of these PCI applications, and I see, web application scanners are supposed to be hitting these web applications. And then what happens? Well, I go to perform an external penetration assessment, and you know what I find? I find all types of vulnerabilities all over these web applications. So I have to take a stand back. I'm like, well, what in the world's going on? I mean, I thought these were supposed to, these are externally facing applications that are either processing, transmitting, or credit card data here. And I'm like, what in the world? If anything, I would expect these to be the really secure things in the environment, right? I mean, if these aren't locked down, we've got some major issues here. So that's kind of what piqued my interest here a little bit. So this is some of my big gripes here with the standard. It's number one, many scanners and web application firewalls, they're not finding the OWASP top 10. They're not blocking attacks that are they're not preventing cross-site scripting and SQL injection type of attacks and a lot of different things like that. And I'll actually go into that a little bit and give you a few examples of how these web application firewalls and web application scanners are not doing what they're claiming to do. And as a byproduct, you get a bunch of organizations that have a false sense of security, right? They're like, oh, okay, well, we just hit the web application with Acuinetics. We should be okay from here on out, you know? We have nothing to worry about. In the meantime, the web application is covered with vulnerabilities, and in some instances, these vulnerabilities can be exploited to gain a shell on the underlying operating system. I mean, these are some big problems. So, for my little experiment, I was like, okay, well, Web Application Firewall, all right, let's take a look at some of these Web Application Firewalls that are already out there, and let's see how well they actually do at preventing the most basic form of cross-site scripting. All right, now the most basic form, in my opinion, was this. I'm able to inject into an arbitrary location in the HTML, and all I'm trying to do is get some sort of stupid alert to pop up on my screen so that it says, you know, XSS or alert or, you know, Hexor or something basic like that. I mean, this is cross-site scripting 101, so I'm not trying to do anything advanced here where I'm inserting into either HTML, existing HTML tags, which is a form of cross-site scripting, you can do that, or hijacking already coded JavaScript. That's another form of cross-site scripting that I see often where I can insert directly into JavaScript that's already on the underlying page and hijack it essentially. But this is, we're talking about the most basic stuff here. So let's talk about the first one. First one here, Armor Logic Profense. All right, so now let me give you a disclaimer. This is out-of-the-box configurations, okay? Because let's be honest, that's what most organizations are doing, right? They're using the out-of-the-box configurations for these web application firewalls. They're putting it in front of their web application, and then they're washing their hands. Well, why are they doing that? Well, let me show you why here. Well, take a look at this quote right here. Profense is a soft appliance which installs in minutes on any standard server, converting it to a full-featured standalone web application firewall that provides full compliance with the PCI DSS and complete OWASP top 10 vulnerability protection.
This is definitely marketing at its finest. So you'll always see this with any type of software or application or whatever.
Yes, yes.
If anybody tells you that something will make you fully compliant or is fully compliant, always question that.
Yes. Now, the thing that I liked the most was the quote here that says "in minutes," because I mean this is in minutes, so they're assuming a default configuration here. So I admit that if you go through and use this this web application firewall to actually do some whitelisting, it would be a decent web application firewall. But how many here can configure whitelisting within minutes? that's a task that takes days or weeks sometimes. So we're talking about default configurations here. All right, and I got this from a white paper on SAN's website here, so I laughed when I read that. So let's see how well this does here. So, all right, I started off pretty well here, right? It blocks that. It blocks script, alert, XSS, script. So I'm like, good for them. Good for them. They know how to code web application firewalls. However, it didn't block that. Does anybody notice the difference? That is all that it took to bypass this web application firewall in its default configuration. Is that not a problem? Does anybody else not see this? This is concerning. So you know, chalk one up to the hackers and 0 to web application firewalls at this point in the talk.
And also the other thing is too, a lot of these different solutions are signature based, and so this is just a prime example of something being signature based.
Yes.
It's all it's looking for is just that other tag.
All right, so let's go take a look at the next one. So I'm keeping my fingers crossed for the next one. All right. So this one, again, out-of-the-box configuration, applicure.defender. Now, this is something I actually got from their website. Now, notice this. .defender not only meets the application layer firewall requirements of PCI DSS 6.6, but also offers comprehensive protection against SQL injection, cross-site scripting, and scores of other application level attacks right out of the box. I want to point that out, right out of the box. That's the key word. So once again, if you take time to do some whitelisting, maybe this isn't the case, but they're claiming that out of the box this is doing this. So what does it take to bypass this? All right, so you can see here, there's the configuration, default security profile. All right, now let's take a look here at kind of how I found how to get something to, or the cross-site scripting to execute. So first, I used the word script, okay? It blocked it. Okay, that's good. I used the word iframe, and it blocks it. Okay, so it blocks the iframe HTML tag there. However, it did not block the div HTML tag. See that? But it did block this next one. This next one is a form of cross-site scripting where you can actually you use the div tag and you use the style attribute and you actually insert JavaScript into the style attribute there. Okay? But it blocked this. All right? Now, I tried to make a couple changes, and what were my results? It executed that. Does anybody notice the difference between these two? Okay, I'm going to give you a second. All right, so there's the one before. Here's the one now. And that. I just changed the word alert to the word confirm. And I got a pop-up. All right, so, and this is a really important thing to grasp here because we all know that attackers write malicious JavaScript with the word alert in it. That's just a no-brainer, right? And I'm just being facetious there. Of course not. An attacker doesn't want to alert you to what they're doing. That would just kind of be silly, right? So this, again, this is signature-based web application firewalls at their finest. They're obviously filtering on the word alert. They're filtering on the words iframe. They're not filtering on the word div, and they're not filtering on the word confirm.
Now, the other thing is, too, to sort of tie this back to some of the other assessments. So your automated tools, a lot of them are going to try these different types of simple expressions, and what are they going to do? They're going to use the word alert. They're going to use the word, cross-site scripting or XSS. So that's the other thing, too. They're kind of making these tools to pass simple vulnerability assessment tools.
So let's take a look at the final one. Now this one was the one that I had all my money on. If I was a betting man, I would put all my money on this. There's a couple reasons for this. Number one is, so out of the box configuration, it said that it blocks top threats like SQL injection, cross-site scripting, and many more by policing the key tactics, blah, 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 blah. But this is what really got me. PCI compliant from birth. This is amazing. I mean, maybe he was PCI compliant from birth, but I sure wasn't. So I'm saying, wow, now this is going to be top-ranked firewall action here. I'm going to have to pull miracles and magic code, and I'm going to have to bypass all type of stuff. And so let's see what happened. All right, so there we go. There's the configuration I used. Out-of-the-box configuration. You see, it's going to block SQL injection and cross-site scripting and directory browsing and all types of fun stuff. So I'm like, all right, let's roll up our sleeves now. All right, here we go. First shot. It blocked it. Okay, iframe, source, JavaScript, alert, bingo. All right, score one for the PCI compliant from birth people. That failed. This executed just fine. Does anybody even notice the difference? Right there. That's all it took to bypass a PCI compliant web application firewall from birth. Very surprising. So you can kind of see now where I'm just a little bit disillusioned by some of this stuff that I read about the PCI stuff, and I'm like, well, I don't think it's really doing its job very well. But you can see how this would give companies a false sense of security. I mean, they're saying, hey, I got a PCI compliant firewall from birth. I don't have to worry about anything. And then all that someone has to do is remove the final script tag or the final bracket, and it executes. So this is kind of scary. So let's go into another example here. All right, so now let's talk about web application scanners. All right. So this is an example. This is an example page I created. Okay, I'm not the best at creating web applications, as you can tell, but it gets the basic point across, right? So you see here that says, please enter your name, and then if you're a new user, just enter the word new user in there, right? And then it says, then you put your employee ID, put your rule in, and you submit your query, all right? Now, you might think that this is silly, but this type of stuff really happens. If you I've performed hundreds of web application assessments, and many times there's directions on the screen that's just like, hey, if you are, you know, the president of Iran, you should put in Iran here, or something like that. I mean, so this type of stuff occurs, where it will actually tell you on the page, do a specific action. All right? So let's see what happens if we obey the rules. All right? We put Bob in here. All right? So what happens? Well, it says, welcome back. And that's all that happens. All right? Nothing big, nothing exciting, right? All right, so let's go to, now what happens if we put the word new user in there? All right? Look at this. It reflects the employee ID back. Now, if I'm an attacker, I'm able to read the screen. I'm going to say, you know what? If it tells me to put the word new user in there, I know that something's up. There's something that's going to be happening on the back end of this web application that's going to be different than if I don't put the word new user in there. So you know how I'm going to test a web application? One of the tests I'm going to perform is to put the word new user in. And as a result, the employee ID gets reflected back. Well, because of that, you can hijack that employee ID because there's no filtering going on, and you get your pop-up to appear. You get your alert XSS to pop up. The point is web application scanners are not going to identify this type of vulnerability. You know why? Web application scanners can't read. They're unable to read. They're unable to figure this type of stuff out. They're unable to read the page and say, oh, okay, well, new user, that's something I should try in here next time with running my next test. But this stuff is real. These are the real, everyday examples of things that I encounter. All right, now this is, I'm not going to go into details on this one. This one's kind of a fun exploit that I've been using a lot more of lately. So it's a form of SQL injection in which you're able to pull all the contents out of an Oracle database, and you're able to do this type of thing through literally string concatenation. So it's based off of true and false parameters and based off of the way the website provides information back to the user based off of a true parameter and a false parameter, things like that. Now, what I've noticed is this is a pretty complicated SQL injection attack, but it works, and I've been able to pull all the data out of various databases using these types of attacks before. But a lot of web application scanners, they're not going to be intelligent enough, or they don't have necessarily the right signatures for a particular situation. So a lot of web application scanners are going to miss this form of SQL injection, which is something that an attacker who knows what they're doing is going to find. All right, and then finally, this is like a logic flaw, okay? So in this logic flaw, you can see real life, okay? This is a fake web application, but this is based off of a real life example of something that I've encountered in the field, okay? So you'll see here that the rule, okay, is set to user, right? And it says, welcome to company portal. Hello, you don't have administrator rights, okay? What do I do? Well, since I'm an attacker, I'm going to play around with that rule parameter there. And if you change it to something like manager, you're now greeted with a lot of additional fun information. Now, the key to this is, it's once again, it's the logic flaw. A web application firewall is not going to detect this type of vulnerability. The reason being is because if a manager logs into the site, they should have that manager access. So it will look like a valid URL. And if a user logs into the site where it says user, the user should have that type of access. That's a valid URL. So in either case, it's a valid URL. It's just that there's a logic flaw behind it, and so that's the main problem. Web application scanners, again, they're not going to identify this type of vulnerability, even if they happen to figure out that the word manager was, gave them additional information. All it would look like is valid HTML that pops up on the back end anyway. So web application scanners, again, aren't going to get this type of thing. All right. So we've kind of taken a look at some of these problems. Another thing to note is I have actually installed vulnerable software that's vulnerable to like different forms of SQL injection, and I've been able to bypass various web application firewalls through that as well, including Barracuda firewalls, Barracuda web application firewalls, which is kind of surprising because that's a pretty high-end web application firewall. So it's not just cross-site scripting. I wanted to keep it to cross-site scripting because I wanted to give one example, but this can also be applied to different SQL injection vulnerabilities as well. So now let's talk about this a little bit. What exactly is wrong here with PCI 6.6? All right, so the first thing that kind of concerns me is this, so they say you can do these web application scans and you'll meet the intent of 6.6. Remember, we're not talking about, you know, an HR site that has just a bunch of garbage on it. We're talking about web applications that are doing something with your credit card. Okay, so you take a look here, and PCI doesn't even require that these scans be authenticated. Okay, it doesn't lay out any sort of guideline like that. So how many of you have gone to like a website where it says create your own account, and then you create your own account, and then you're dropped into, you know, the full version of the site that's tied to your account? Well, PCI doesn't come flat out and say, hey, by the way, if you can do all this stuff, then this has to be an authenticated scan. So that's a problem because a lot of times we kind of get this M&M security, right? So the login page is all crunchy and hard, and you run your web application scanner against that. The web application scanner finds nothing. However, when you log into the website, you're greeted with all types of fun vulnerabilities, and you know it's the playhouse of vulnerabilities. I mean, you get SQL injection, cross-site scripting, directory traversal. It's all over the inside of the app, but you're not going to find it on the outside of the app. So to me, that's a problem.
So, here's my response to that. So currently there is no standard for how these things are actually completed. So there is no standard of a code review. The guidance, the additional guidance, just says, hey, do a peer code review, have a third party look at it. Another good example of a good review would possibly be someone doing a static code analysis, such as like VeriCode. The problem is that there's nothing sort of saying, hey, I know how to use my tools, or B, I have these tools, I know how to use them, but no one's saying that I have to do this. So what I'd do is I'd encounter a lot as a QSA would be organization X has to have a web application vulnerability assessment performed. Well, what ends up happening is they just look at that one first part of that web page, and they don't look at anything else. And from a PCI standpoint, you're compliant. But as a security standpoint, you're not compliant. So one of the always things I always preach to people when they're going through PCI process is compliance does not always equal security. Another issue that always comes up is resource availability. So you may not always have the ability to hire someone to do all these code reviews if you're a smaller organization, because there's a lot of smaller organizations that take credit cards. And a lot of times too, they might not have the resources to actually perform code reviews. So in some cases, you have to sort of identify, you know, what's the best case scenario for your company? Can you perform all these stuff? Can you buy these tools? Can you actually accomplish these type of code reviews?
Yep. And my quick response to that would be, number one, on the bottom here, if the company cannot afford to have this stuff done correctly, then I don't think they should be taking the credit cards at all. Because quite frankly, they're playing with my information, and so I don't see. I think that's kind of, in my opinion, not a real good idea, right? I mean, if you can't pay for it, then you probably shouldn't be taking them. Maybe you need to find a different way around it. And then finally up here is, yeah, the organizations are performing these web application scans on their own a lot of times, and they don't know how the tool even works correctly. They just point the scanner at the web application and blast it away. But even more than that, PCI doesn't give you a lot of guidance, right? I mean, so it's just saying, hey, perform some assessment on the web application. So it doesn't say that it has to be authenticated. It doesn't have to, it doesn't give you a lot of guidance there. So blasting a web application with a scanner in the front page isn't a really good idea. It doesn't seem like they thought that through a lot.
Right. And so basically, the other thing is it's just a tool.
Yep, exactly. This is the other thing here is PCI DSS 6.6 is not protecting web applications from logic flaws, right? So I showed earlier how we can change, user to the word add to manager, or we could make some sort of change like that and gain access to the web application. And these are real life scenarios. So for example, I was performing an assessment just the other day, and at the very end it said, here's your receipt, okay? And I got this receipt, and there's a bunch of sensitive information on the receipt. I take a look up in the URL. It says receipt, it's like number equals 1115 or something like that. So I was like, oh, okay, well, what happens if I change that to 1114? Sure enough, somebody else's receipt pops up. What if I change that to 1113? Bang, another receipt. I'm like, wow, this is fun. So I throw a burp against it, which is a web application proxy. I just start iterating through all those numbers, and before you know it, I have all this sensitive information. And so this stuff is real. and I come across that all the time. So we're not talking about hypothetical in lab situations here. This is real stuff. So it's not checking for that, right? I mean, web application scanners aren't going to be able to identify that, and web application firewalls aren't going to be able to block against that, because it looks like normal traffic. Point blank, let's be honest, scanners cannot think like an attacker. And like I said, the web application firewall doesn't even know to block it.
So the other thing is that, so my response to this whole entire argument is, all these different tools or assessments are supposed to be looking for one thing. You're supposed to be looking for vulnerabilities identified within requirement 6.5. These requirements tied to the OWASP top 10. They also can tie to, so like let's say if you want to use other standards, you can also use the SANS CWE top 25. You can also use the secure coding practices as well. And once again, the standard itself doesn't say look for business logic flaws too, because there's just no good way to identify that type of vulnerability. There isn't a CVV code or there's not a CVE database on business logic vulnerabilities. The other thing is hopefully if you have to do a web application vulnerability assessment, some of these things are being identified within your penetration test. This also goes back to, is your company that's doing your penetration test doing a good penetration test? Can they find these things that these normal automated tools can't find or static code analysis can't find? And so hopefully that's the part where I think they're trying to interwork the different types of assessments. However, in many cases, I've seen poor penetration testing, where someone just basically did a vulnerability scan and said, hey, it's a pen test. Once again, it's all about striking a balance between automation and a real person doing the work.
And let's be honest, sadly, a lot of organizations are going to go with the cheapest company. And the cheapest company, they're going to take Nessus, they're going to blast the external website, and they're going to say, there you go, there's your checkbox. You've now had an external penetration assessment performed. So what's sad is PCI 6.6 isn't doing its job, and now neither is the penetration testing requirement as well. So that could be a completely different topic that would last a long time, but let's just leave it at that for now. All right, objection 3, next problem. Based off my examples, web application firewalls and scanners, when it comes to the OWASP top 10, they're not going to identify all these vulnerabilities, right? I mean, based off my examples, I gave a couple of them. It's just the way it is.
So my point here is essentially, whether it's a manual or an automated assessment that's being performed, there's always going to be something that's going to be missed, because that's just the nature of our business. We have a bunch of vulnerabilities. There's always zero-day attacks. There's things that aren't going to be found. Something new is going to pop up. So there's always going to be something new that's going to be found. Just like any other type of firewall, like a network-based firewall, there are going to be flaws within it where you can bypass it. Just like a web application firewall, you can bypass it, just like Gary was showing you. The problem is that we have to use is a layered approach. Not one thing is actually going to be able to solve the issue. Even let's say the technology for web application firewalls improves significantly within the next year or 2 years or 3 years. There's still going to be issues that you can find that those applications just might not be able to look. Maybe they will look for business flaws. Maybe we'll be able to implement those technologies a little bit better with better whitelisting and blacklisting. And maybe they'll have better signatures where they can find stuff. But still, there's going to be other things that can be found.
And at this point, I'm just going to say this, is let's go ahead and bring this to the level of 0 day. So yeah, I concede that there's always going to be ways around these web application firewalls and around, just like there are network layer firewalls. But for Pete's sake, it shouldn't be removing a bracket. Let's get this down to the level where it needs to be. Let's start doing some whitelisting. How about PCI makes it so that whitelisting is the standard instead of this garbage blacklisting stuff? That's my take on it. Let's make it a little bit more difficult for the attackers. Finally, this one here, and this is the one that that really bugs me, is so the web application firewalls and web application scanners, there's little guidance. The PCI Council is giving very little guidance as to what is an acceptable web application firewall and what's an acceptable web application scanner. And this is what really gets me. So I have to do this ASV recertification thing every year because Secure State's an ASV, which means that we have to perform these external scans against different organizations' PCI zones. And I have to jump through so many hoops in order to get this stupid certification. All right, how come these web application scanners and web application firewalls don't have to go through some sort of certification as well? How come they don't have to stand up a web application in front of a vulnerable web application firewall and say, how many of these attacks are you going to block today? I mean, where is this? Where's the certification? If we're going to make PCI all about certification, then let's certify these things as well.
I kind of agree with this one. I didn't really have any issues with it, but the thing that I started finding too is, especially when it comes to application scanners, or whether it be a web application assessment code review, additionally, whatever, the thing is that the guidance, such as what was provided in the previous slides, they just basically have a list of thou shall do this. They don't have any guidance or better understanding or better guidance on what you should do from a procedure standpoint. If you don't have those procedures, people are going to do the bare minimum, and they're just going to meet the highest level of the requirement. And it's kind of sad in that regard that people don't think of, oh, this is just a thou shall, and I really need to make up a better process internally to run these type of assessments or these tools or this vulnerability code review. And once again, payment applications that are on a Visa PCI list or Visa service provider list or what have you, they all have to go through a certification process. So is the ASV scan process, where all it is a vulnerability scan that you're doing on the external side. So if you're using these type of tools and they have to be validated, why on earth are these tools not validated in some way, shape, or form?
All right, and we're going to quickly wrap this up because I think we're almost out of time here. So let's just go through these real quickly here. So what's the answer? Real quickly, compliance does not equal security. So get that out of your head, and let's start thinking about how we're going to actually secure our organization.
Well, here's the other thing, too. It's not necessarily in our heads. It's really in the management's heads. And that's the fight that I was always fighting with within PCI. Every single time I go into an organization, you're not secure. You're not PCI compliant. You're not doing what you're supposed to be doing. They don't care because it doesn't affect their bottom line. And so I think, once again, as I've heard in several other presentations and different organizations and podcasts and what have you, it's all about communicating that up to upper management. If they don't understand that compliance does not equal security, or that compliance is not the bare minimum, at least, possibly, it needs to be communicated that they have to do risk assessments and understand what their true risks are and what they really should be doing above compliance to meet their security needs.
And then this, the second one here, we've already touched on that. The third one here, better secure software development lifecycle. Companies really should have a good SDLC in place where they're vetting out these vulnerabilities in the early processes. I mean, it should actually be part of the very development of the web application from the very design phase of the application all the way through. So we need a real SDLC. There's some good, there was Kevin Johnson's presentation, Ninja Developers and Application Security Testing, and your SDLC. That he presented in at OWASP, and then also this layered approach to security. So it shouldn't be web application firewall or manual assessment or vulnerability scan or something else. It should be all of these things. I mean, really, we should be layering this security. And I think that's it.
Well, I got a few other things on that other part of the software development lifecycle. So to give some examples of some things that could definitely improve that is, and these are some of the ideas that Kevin Johnson also gave out, perform those web application vulnerability scanners, so take those tools and run them in the pre-production portions of your software. Get the low-hanging fruit as fast as you can before you start pushing it out to production or a staging environment. The other thing is, too, is do those code reviews, do those other things in combination of. So that when your system is about, or your application, your code is going to get pushed out to production or to staging environment, then you actually have someone that knows a little bit more and can find the more high-level things or more complicated things that that software, those tools just can't find. And once again, that goes back to the layered approach. It's not just one thing, it's all of these things, because all these things combined, they're going to equal something that's a little bit better than what we're currently doing. When we go back to the layered approach and basically doing all these manual assessments, it's really a shame that we don't think about this. And once again, it goes back to the financial issues and management issues of management saying, hey, we don't want to do this because it's just going to cost us a bunch of money. And so once again, it's doing all of them. And maybe even assessing whether or not maybe all of them, you can't do all of them, but at least pick out the best ones that'll get the best bang for your buck.
Yep. All right, well, we're going to wrap this up now, and we thank you guys for your time, and we appreciate you guys being here, and let's go out and make some secure web applications, whatever that means.
See ya.